Today we are going to continue reviewing place value. We're going to be working on place value and how to represent a number different ways. Let's watch this video on place value to review how we can represent a number.
Awesome slam dunk! What's the score? No, Moby, the game is not tied. They scored 6 points, which is the same as 6 ones. We scored 16 points, which is the same as 1 10 and 6 ones. What is place value? Numbers can be made up of just one digit. But numbers can have more than one digit too. The number 6 has only one digit. The number 16 has 2 digits, 1 and 6. Each digit in a number stands for a group. The value, or how much each digit stands for, depends on its place in the number. This is called place value. What are ones? Let's see. How many cubes do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 cubes. When you count things one by one, you count up by ones. When we write the number 9, it's in the ones place. Some numbers have more than one digit, like the number on my shirt. What are tens? When you combine 10 ones, you get a group of 10. On a 100 chart, each row has 10 ones. You can combine tens and ones to make a 2-digit number. Let's see. We've got one group of 10. We also have 1, 2, 3, 4, 5 ones. So we have 15 cubes. The digit farthest to the right shows how many ones we have, 5 ones. The digit next to it shows how many groups of tens we have, 1 group of 10. Right, you can show the number on a 100 chart too. That box has 64 crayons. That means there are 6 groups of 10 and 4 ones. So that's 64. You can show this number on a 100 chart. I've definitely seen numbers that have 3 digits. What are hundreds? When you combine 100 ones, you get a group of 100. Right, Moby. You can also get 100 by combining 10 tens. Let's see. We have 1 group of 100, we have 3 groups of 10, and we have 8 ones. 100 plus 3 tens plus 8 ones equals 138 cubes. That puzzle has 375 pieces. That means there are 3 groups of 100, 7 groups of 10, and 5 ones. So that makes up 375. Yeah, it is a big number, but there are even bigger numbers. What are thousands? When you combine 1,000 ones, you get a group of 1,000. 100 tens also equal 1,000. And 10 hundreds can make 1,000. We've got a group of 1,000, 2 groups of 100, 4 groups of 10, and we have 9 ones. So we have 1,249. Right, Moby. You put a comma between the thousands and hundreds place. I don't know if we'll ever score 1,249 points, Moby. It looks like we need a new scoreboard.
Our learning target today is I can understand that the 3 digits of a 3-digit number represent amounts of hundreds, tens, and ones. Let's learn that with our mirror words. Mirrors on. I can understand that the 3 digits of a 3-digit number represent hundreds, tens, and ones. Let's do it again. I can understand that the 3 digits of a 3-digit number represent hundreds, tens, and ones. Mirrors off. Great job. Make sure you go teach that to somebody today. Now we are going to practice reviewing boxes, sticks, and ones. So one way to represent a number is to use a proof drawing. How can we represent 587 using a proof drawing? We can draw 500. So we're going to draw 5 boxes. And then we have 8 tens, so we're going to draw 8 sticks, making sure to leave our 5 group. And we have 7 ones, so we're going to draw 7 ones, also making sure that we show our 5 groups. Now, looking at this drawing, what does this proof drawing represent? Well, I have 5 hundreds or 5 boxes. I have 6 sticks, so that's 6 tens or 60. And I have 4 circles, so I have 4 ones. 500 plus 60 plus 4 is 564. Now let's practice representing our numbers using a different way. So I'm going to draw a number here using a proof drawing. And I have 2 hundreds and 6 tens and 7 ones. So if I look at that number and I want to build it with my secret code cards, how many hundreds do I have? That's right, I have 2 hundreds. And then how many tens do I have? Look at my sticks. That's right, I have 6 tens or 60. And how many ones do I have? I have a 5 group plus 2 more, so that's 7. So I have 7 ones. So I can also build this number using my secret code cards. And when I break it apart by place value, I have 200 plus 60 plus 7. But if I put them together, I get 267. Same value as 200 plus 60 plus 7, but just represented a different way where we can see them in their place value positions. Let's try another one. My board. This time, I'm going to put a number up with digit cards, and we'll need to make a proof drawing that will match it. So the number I'm going to put up is 400 plus 30. Oh, where did that go? Plus 8. So this number can be read 400 plus 30 plus 8. And I can put it together so that it's 438. But if I take it back apart, it'll make it easier for me to be able to draw my proof drawing that goes along with it. So how many hundreds do I have? That's right, I have 4 hundreds. So I'm going to draw 4 hundreds or 4 boxes. How many tens do I have? That's right, 3 tens and 8 ones. Now, when I draw my 8 ones, it's really important that I make my 5 groups. So I have 5 plus 3 more is equal to my 8. Let's try another problem, and let's make this one a little bit tricky. First, let's clear our board. And we need to change to this work map. All right, I'm going to put up a number, and we're going to try to figure out what number it is. So, try to guess my number. What number do you think that is? If you guessed 528, you are correct. Remember, when you have a 3-digit number, the number that has all 3 digits in it needs to go first. So even though my 20 was first before, the 500 goes first because the 5 has to go into the hundreds position. Then I can have my tens and then my ones. So if I put that all back together, I get 528. Now that we've reviewed place value, let's use that to help us add or subtract 100 to a number. So if I have the equation 259 plus 100, that means it's 100 more. So if I were to draw that out, 259, if I'm going to add 100, then I'm only going to be adding 100 to my hundreds position. None of the other digits are going to change. So 259 plus 100 is 359. It's 100 more. Now let's try 2 more problems. 421 plus 100. So I have 400s, 2 tens, and 1 1. I'm going to add 100 to my hundreds position, and that changes my number from 421 to 521. Let's do this next problem, 458 plus 100. Now, I know that I'm only adding 100 to my hundreds position. So 458 plus 100 is 558. Now let's practice using that same strategy to help us subtract. So I have 678 minus 100. Let's draw that out. 670, this is a big number, 8. Now I'm going to take away 100 this time. So I'm not going to add to my proof drawing, I'm going to be taking away. So I'm taking away how much? 100, that's right. So we're going to cross off one of our hundreds. How many hundreds do we have left? That's right, we have 5 hundreds left. Now our tens and our ones stayed the same. So we have 578. Let's try this next one. 344
minus 100. Now, I'm only going to be taking away from my hundreds position because I have a 0 in my ones and a 0 in my tens. So if I take away 100, how many do I have left? That's right, 200. And then my tens stayed the same and my ones stayed the same. Let's look at this last problem. 872 minus 100. So I'm only taking it away from my hundreds. So 800 minus 100 is 700. So 872 minus 100 is 772. Now let's practice adding over 100 using the make 100 strategy. So if I'm going to add 497 plus 5, I want to find a benchmark number or a friendly number. And those are numbers that are multiples of 10 or 100. So is there a number close to 497 that's a benchmark number? That's right, there's 500. So I want to break apart this 5 to find an addend that I can add to 497 to equal 500. So 497 plus 3 more would give me 500. Well, what's my other addend that goes with my 3 that would give me a total of 5? That's right, it's 2. So 497 plus 3 is 500, plus 2 more is 502. We can check that with a number line. So if we start at 497 and we add our 3 to get to that benchmark number of 500, then we're going to add our other addend, which is 2, and 500 plus 2 is 502. Let's try another one. 695 plus 6. What's my next 100 after 695? That's right, it's 700. So I want to break apart my 6 to give me an addend that I can add to 695 to make it equal to 700. Well, if I add 5 to 695, that would give me 700. My other addend that I would need to add to the 5 to equal the 6 when I break it apart is 1, because 5 plus 1 are equal to 6. So 695 plus 5 is 700, plus 1 more is 701. Let's check that one on our number line. 695 is our starting number. We're going to break apart that 6 into 5 to get to my 700, my benchmark number. And then I'm going to add my other addend that's left over, which is 1, to get to 701. Let's try one more problem. We have 394 plus 9. How can we break apart our 9 to give us a number that we can add to 394 to make it equal to 400, which is the next benchmark number? That's right, we could break apart our 9 into 6 and 3, because if we add 6 to 394, that will give us 400. And then we can add 400 plus 3 is 403. Let's check that. 394 plus 6 is equal to 400. And then we still have 3 more we need to add, and that gets us to 403. Now, this is a really great strategy for being able to do mental math, because if you can break apart those numbers and add them in your head, then you'll get so good at it that you won't need to write it down on paper.
Let's review our learning target. Mirrors on. I can understand
that the 3 digits of a 3-digit number represent amounts of hundreds, tens, and ones. Mirrors off. Great job doing your learning target today and all of your hard work. Don't forget to do the practice. See you next time.